this is a presentation of machine learning project. Our topic is trigger-board classification. We will try to find a more precise method to distinguish boards and numbers for Twitter accounts. First, we should know that there are more and more bot accounts appearing in Twitter. A bot account is an account operated by a robot who are acting like a real person. Some famous websites will use bots to help them reduce the burden of publishing recent news, but more bots are created to disturb people or offering meaningless information. Therefore, we need to find a proper method to discover bots. Second, in the project, we will use the machine learning method to classify bots from real human accounts. Our method will be based on pre-existing algorithms. We have also collected a dataset of Twitter accounts as our training samples. Now, let's discuss our dataset first. In our dataset, we have collected 19 features for each Twitter account. There are four types of features. First type is text feature. Some of them are useful because they contain important keywords. Some of them may be meaningless. Second one is numerical feature. This kind of feature usually has a large range of value. We need to find the best way to divide the range. Third one is Boolean feature. This feature is easy to handle. Fourth, other features. These features will not contain any useful information for our classification. Therefore, we will not consider them in training. For first three features, we need to process related data before the training, as what we have mentioned before. For text features, we need to find whether there are keywords in a specific data. Then, we will use 0 and 1 to represent this data. If a text feature does not contain valid keywords in all related data, we will not consider it in training. For numerical features, we should clean the data first, because some samples may lose related data. If too many samples lose the data as a numerical feature, we will drop it. Otherwise, we will use mean values of valid data to fill the blank. Besides, we need to divide the range of value for a numerical feature. According to the test, to divide the value range into three parts is enough. For Boolean features, we also need to clean data first, then fill the blank with higher frequent value. After pre-processing, we could check our results. There are only 8 features left, 4 for text features and 4 for other two types. In screen name, description, name and status, we could find some of samples would contain words like bots, robots, and alert. They are important keywords for us to distinguish bots and numbers. While other 4 text features do not contain useful information, in followers count, friends count, lists count, status count, there are few invalid data, and we could use the training results to find the best division of each value range. While other numerical and Boolean features contains too many invalid data, it will reduce the precision of our training results if we set an improper value for each blank. Therefore, we could only drop them. Now, we can use these features to train.
As for training and fitting the data, we will use 5 metrics who are accuracy, precision, recall, F1, and area under curve. Also, as shown in the chart in the right, we have split the training set into 80% and 20%. We firstly use the 80% of the training set to fit the models, doing cross-validation within the 80% training set at the same time. When we receive satisfying results by adjusting the feature scaling, parameter learning, we then check the generalization capability of the model against the reserved 20% training set. After we have the solid model, we can fit the model again with the complete set of training data and test the model with the test data on Kaggle. And here is the result from the 80% data cross-validation. Here we use 4 different algorithms for benchmarking: Bernoulli naive Bayes, decision tree, random forest, and neural network. We can see decision tree and random forest have the best performance in general. That's because decision tree model itself has not overfitting the data. So, as the result, random forest doesn't bring too much improvement to it. We also see that because Bernoulli naive Bayes can only deal with Boolean type features, so its performance is as we expected, lower than other models. As for a neural network, we selected it in the first place to check whether the problem would be better to be fit with a nonlinear model. And it turns out that using nonlinear model neural network doesn't have much advantage. Next, we use the model to predict on the 20% reserved data. Here is the resulting confusion matrices. It shows that it's coherent to the cross-validation we did, with neural network having the lowest accuracy and all other three models having pretty similar performance. Here's another view of comparing the four models. All of them receive approximately 86 to 87% accuracy, which is slightly lower than the cross-validation, which were 88 to 89, but it's within the error. We also tested with logistic regression, gradient boosting, and support vector machine. They all have the very close accuracy performance. So actually adding more features would have added the overfitting. So we keep the current features dimension. And finally, we can train our model against the whole complete training set and test it in the Kaggle taste set. Since the test data in Kaggle is more pure, meaning they have lower entropy for each feature, so both naive Bayes and algorithms that work with categorical data like decision tree, random forest fit pretty well and have good performance. And nonlinear regression model like neural network, it's actually overfitting the problem. And finally, the evaluation of what went well and what we can do more. What we did well was we have actually analyzed a lot of features combination so that we can select the best combination to fit a model. Also, we have selected the best feature standardization method. And the last one is we have tested as many as algorithms as possible, like we mentioned before, logistic regression, Bernoulli, naive Bayes, random forest, decision tree, and gradient boosting. The things we can do more are selecting more kinds of features into consideration so that we can have more types of data of the Twitter account for analysis. We can also use a larger sample size so that we can predict more and with a better generalization capability. And also the last one is we could improve our keyword extraction. Like besides the wording of robot or boards, we can extract more sensitive word to make it into features that we can train the model. And here's the end of our presentation. Thank you.